Welcome to the 3.3 homework. I thought it'd be good to look at a few problems together and then do them together as needed. And so this is the beginning problem. There's a few that I went through and kind of marked that would need to happen. Some of them are going to be easy, just like this one. They just want you to rearrange the things so that it's an if-then statement in this conditional type of environment. So if I look at the drop-down menu, it says you can do it if you read it in the newspaper. And so it's if you read it in the newspaper, then you can do it. And they just want to make sure that you're able to translate those if-then statements correctly. And so let's take a look at this number 2. Now, it says write the statement in the form if P then Q. So no person in Illinois is not in North America. And so if we read that carefully, we want to put in, you can read through the questions too, right? So if a person is in North America, then the person is in Illinois. So it says no person in Illinois is not in North America. So if a person is not in Illinois, then the person is not in North America. And if a person is in Illinois, then the person is in North America. And so they want to choose the correct if-then statement. So, it's if a person is in Illinois, then they're in North America is what we should choose. Let me click off of that so we can stay here for a minute. So if a person is in Illinois, that's what this means. No person in Illinois is not in North America. That means everybody that's in Illinois is in North America, or if you're in Illinois, then you're in America. And so they just want you to start to read it at that level. And so they'll give you some examples there. This continues here. So this is interesting, right? Decide whether the statement is true or false. If the antecedent of a conditional statement is false, then the conditional statement is true. Decide whether this statement is true or false. That's true, right? Anytime your antecedent is false, anytime that if part is false, then it's automatically true because you're not making a statement about that. So we know that it's true. So it's either A or D. And A says whenever the antecedent of a conditional statement is false, the conditional statement is true. I believe that's the one. Let's see what B says, whether the antecedent of a conditional statement is true or false. No, that's not true. And I apologize, I am having kids in the background potentially make noise that you can hear, but enjoy the entertainment if it comes across. So we have these types of works right here. So we check that answer and then take a look at 4. So 4 is asking us to decide whether a statement's true or false. And so if Q is true, then P and Q implies Q is true. Okay, and so we would need to look at a truth table for that and make sure that we have what we need. So keep in mind, if Q is true, we don't know anything about P. So if Q is true, take a look at that last. This is very complicated because we don't know anything about P or R. So I'm going to just make this bigger as we talk. I think what we need to harp in on is they're only letting us know Q is true. So we're going to have a big time problem creating a truth table. I mean, we could create one, but we don't know what we don't know what P and R are in terms of being true or false. So this is an and statement. So if Q is true, Q implies R. If R is false, then that's false. If R is true, then that's true. But we wouldn't know about P at all. And in order for this to be true, this first part right here, the P and Q or R, both would need to be true. So let's focus on the last bit. The last bit says Q is true. So remember our truth table for the conditional. Let me see if I can easily go out here to notes. I wasn't thinking about needing a new notes section, but here we are. Remember that truth table for P implies Q. So here's PQ and P implies Q. So it could be true, true, false, false, true, false, true, false. And remember what happens let's go through. So this is true right here. This is the only time it's false. False implies true is always true. So look, whenever Q was true, whenever that consequent was true, the whole thing was true. And so that's what we need in order to answer this question. So you could spin your wheels a lot and think, well, I don't know anything about P and R. That's right. But because Q is true, the whole thing's going to be true. So let's go look at the last two statements. Because Q is true, the antecedent P and Q slash R is true. Well, we don't know that. We don't know whether that's true or false, but what we know is that it wouldn't matter. That antecedent, true or false, right? True or false, would yield a true result if Q is true. So look at the reasoning for the last one. The statement is true because Q is true. And then P dot implies Q is automatically true. That's the one that we want. That third consequence that I mentioned in the videos that were before. Okay. Now, I think we're going to be doing pretty much the same thing for a while. So let me go to, I wrote down question 6. Let's take a look at this as a representative of really 5 through 8. That's what I wrote down. As I do this number 6, I'm really doing 5 through 8. So S is going to represent she has a pet turtle. Let T represent he trains dogs, and let R represent they raise pigs. Now notice in our question, there's no T. That's because they want to ask a bunch of questions off of the same setup. So what we know is that S is she has a pet turtle, and R is they raise pigs. So what we have now is if they raise pigs, she does not have a pet turtle. So R is true, so R represents that they raise pigs. So let's look for if they raise pigs, then she does not have a pet turtle. I think it's that C one. And they just want to make sure that our knowledge of the symbols that they're using makes sense, and that we always recognize that these symbols represent just different statements that could be there. Let's go to look at number 10, which would be representative of questions 9 through 10. And we're going to establish a truth table. And so if here they're saying, hey, construct a truth table. So we're going to take it to us one line at a time. And so we're going to need to be really careful about this. So I would recommend doing this on the side. But we did something similar to this in the video that I did. But if I just do this first one, let's go back over to our notes. And I need to write down a few things. So what we're looking to do is not Q implies not P. I won't remember. I'm getting old. I don't remember too much. So I think later on you'll learn a name for that. So not Q implies not P implies Q and P. Let's make sure I copied that right. And they want us to establish a truth table. Not Q implies not P implies Q and P. So let's see if we can just do this first one. And so what we know here is that P is true as they start us out, and Q is true. And so we're going to need a not P and a not Q. Okay. And so what we know right now is we're trying to fill out this line. Now, I think personally I need the big information here. And so as I come in here, let me see about using different pen color to see if I can help out a little bit more. And so not P would be, these would both be false. Well, if I do that, come back in here, let's do the not Q implies not P. Well, this is going to be, I'll put it in blue here, this is going to be true. Because anytime your antecedent is false, you have a guaranteed true statement in a conditional like that. So now I have true. Now I need to look at the second green thing right here, which is going to be Q and P. So remember, Q and P, they're both true. And so we get a true statement overall. It's the only time that can be true. And so now what I'm looking at, and maybe apologize, let me do something that I think will be helpful. Let me put that in green. So we got a true statement out of that green for the first one. But that's not even what they're asking for in the end. In the end, they want to know about the big implication. I haven't used red yet. Well, I kind of have, but we're looking at that red implication there. And true implies true. That's true. And so if we come back here, we'll say, hey, that's true. And then they'll give us an opportunity to check it. Now, it'll be a final check because that's the case. So let's do the next one just for emphasis. And this is the last example I think that I need to do. I'll look at some others just to make sure. But let me make sure I have the black pen color. I don't. And so we're going to add another line here. But now we have the structure that we need. And so let me make sure I have it the same way. True, false. Yeah, they're just going to do it the same way. So true, false. And so not P, using the same coloring that I did before. Not P now would be false. Not Q now would be true. So now we got not Q implying not P. So remember, we're going this way. True implies false. That's the only time we're false. And so let me switch to blue. And so that's false. Q and P. Well, Q and P would be back here. That's going to be false as well. But I apologize, I should do that in the green. And so overall, well, we have false implies, well, I didn't even actually need to figure out the green. Because the antecedent is false, the whole thing is true. And we're going to come back here and put a true and hopefully get marked correct. Yep. And we're going to just keep that process going and building this truth table. So you'll have a few like that. Let me just take a look ahead. Sorry about that. It knows I haven't completed. Now here, they're just looking for us to write an equivalent statement. So this is 13. So there are a couple more that I'd like to show, at least one more here. Write the statement as an equivalent statement that does not use an if-then connective. Remember that P implies Q is equivalent to not P or Q. If she planted those flowers, then they are tiger lilies. So in our case, I don't think I can draw on this screen, but in our case, P is she planted flowers. So I'm looking for she did not plant flowers and the use of the word or. So I see that the first three have or, so they're in the line. So D is automatically out because that's an or statement. Not P would be she did not plant flowers. That's the first two. And then Q is they are tiger lilies. So because of the equivalency, I'm looking for her to not plant flowers, or they are tiger lilies. So it looks like it's B. So B has the not P, has the right or, and it has the Q as tiger lilies. And so they just want you to get familiarity with that. And let me just see what this one looks like. Okay. Use truth tables to decide whether the pair of statements are equivalent. Okay, so remember what we said before. We had some equivalencies of the statements there. And let's remember what they were, right? So I could bring back that video, but let's just come in here and you would want to write down the equivalency statements that were found in 3.3. And remember, the negation of P implies Q is equivalent to P and not Q. So let's remember that, right? We'll have that written down when we come to do the homework or the exam. Well, that's what we have there. We have P and not Q. So that's a true statement. We have the negation of P implies Q, and we have P and not Q. So we're looking for a way to say that it's true. The statements are equivalent, so it's one of the first two. The statements have the same truth value for all values of P and Q. The statements have different truth values only in the case when P and Q are both false. Okay, so we may have to actually write out the truth tables to see whether they're true, but we definitely know it's the first two. And we could do that really quick. So let's go look at the truth tables. Okay, so if I go to establish the truth tables, remember we have P and Q, and true, 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 false, false, true, false, false. Right? We'll get really good at writing these truth tables. And then we have, let's do this first one. Let's do P and Q. Remember that it's true almost always, definitely when the antecedent is false and when they match up, but only false once. And then remember, we're taking the negation. So we'll do it in blue. I'll underline that in blue. The negation of P or Q. So that is, and let me come in here and extend these lines a little bit. Sorry, I didn't think about that before. And I'll do it one more time here. Okay. And then, so the negation would be false, true, false, false. Now let's look at P and not Q. So remember what not Q is. So let me do that in green. So not Q would be false, true, false, true. So I'll just put those in the little corner there of the Q. So I'll put not Q. Just sneak it in there so I don't have to do too much. So I want to look at P and not Q. So remember, that's the and statement. So they both have to be true. If any one of them is false. So this is false. This is true. And this is false. And this is false. Because at least one of them is false. So this is P and not Q. So obviously they match up. That's what we were trying to say, that they're equivalent to one another. But let's read those statements again, because we have to choose the reason why. The statements have different truth values only in the case where P and Q are both false. So let's go look where P and Q are both false. And they have, the statements have different truth values only in the case when P and Q are both false. So there's where P and Q are both false. And the statements do have different truth values. No, they have the same truth value. So yes, so it's got to be B. And maybe that was a waste of our time. So what did B say? They have the same truth values for all values of P and Q. Of course, that's the only way they would be equivalent. I apologize. I thought there might have been some idiosyncrasies there, but of course they'd have the same truth values for those statements. Otherwise, they wouldn't be equivalent. And so they were using a false rationale with the true statement. So that's the way this looks. Now there's other questions in here, but I'm going to save them to a different video because they deal with circuits. So I'll make a different circuits video. That way this one doesn't